Hello children, in ray optics we are going to see dispersion of white light through the prism. See, the splitting of white light into the component colors passing through the refraction of the medium, which we can know that it is a dispersion of light, right? See, that we can say the colors of component colors, which is with GR colors. So that are all, we know that violet, indigo, blue, green, yellow, orange and red. See, white light consists of a continuous range of the wavelengths, which we can say, and the white light which passes through that prism, it is splitting the ray, the component colors, which is we say, and it contains from 400 nanometer to 700 nanometer. The dispersion which takes place, the refractive index of the refracting medium, you can see, is different for different wavelength, right? See, the sigma red, you can see that, which is deviated angle between red to violet, you can see that ranges from 400 nanometer to 700 nanometer, right? Now, mu v, which is equal to sin I by sin RV, and mu R red, for red, which is equal to sin I by sin R we can say. See, since the mu v, that is refractive index of violet, is greater than mu R, and we can say RR is greater than RV, right? So the colors and refracted at different angles, so that it is getting separated due to the reason, right? Now, what is the dispersion? Also, we can explain through the Cauchy equation, which is nothing but this will helps to know the refractive index of the material of the wavelength. See, wavelength, which we know that lambda, that mu, which is equal to A plus B by lambda square plus C by lambda par 4. So we can take the A, B, C are the constants, and the value of which depends on the nature of the material. And also for a small angled prism, we can say the deviation, that is sigma, which is equal to, we know that, right, A into mu minus 1. Here we have to take it, lambda, which is wavelength of violet, is less than wavelength of red, or we can say mu v, which is greater than mu r. So the red color is deviated at the least and the violet color is deviated at the most. So the other colors and all, it is deviated by the angles between the sigma r and sigma v. See, so that the different colors of white light get dispersed on the refraction through the prism, which we see, right? So as we said that sigma, which is equal to A into mu minus 1 from Cauchy's equation. So therefore we have taken the sigma v is greater than sigma r. That also we said that because of due to within these ranges and deviated the red color least one, violet one is the most. So that we get sigma v is greater than sigma r. So the colors are separated with different angles of deviations. Violet is the most, we said, red is at least color. What is the angular dispersion? The angular dispersion, which is nothing but, we can say, when a beam of white light which passes through a prism, so it gets dispersed into their constituent colors or their component colors, we said. See, we have taken sigma v and sigma r. And the sigma, which is nothing but the deviation angle, deviation for the violet, red and yellow, right, which are all the sum of their respective colors. And the angle between the emergent ray of any two colors is called angular dispersion between those colors. So it is the rate of change of angle of deviation with wavelength. that phi which is equal to d by d lambda of sigma. So d sigma by d lambda, right? So next we can see dispersive power. So what is dispersive power? It is the ability of the prism, the material which cause the dispersion. So this is, we can define this as the ratio of the angular dispersion to the mean deviation, right? So the dispersive power, we can call it as the denoted letter omega. Omega which is equal to angular dispersion by mean deviation, we said. That is means what? Sigma v minus sigma r by sigma. That is the meaning. See, omega which is equal to phi by sigma, that is nothing but sigma means sigma v by sigma r by 2. So in between that we have to take the angular separation between the two extreme colors, which we have take it as angular dispersion, so that the sigma which is equal to sigma v plus sigma r by 2. So also omega which is equal to, as we said now, sigma v minus sigma r by sigma. That is nothing but the angular dispersion by mean deviation, the ratio between the two. So we have taken. Or we can call the omega which is equal to mu v minus mu r into a whole divided by mu y minus 1 into a. So any one color we have to take, right? The material of the prism, we have to take any one color, right? See, this mu v minus mu r into a, how it came? Because of, from the before equation, see that omega which is equal to sigma v minus sigma r by sigma. That we can take that sigma mu v minus 1 into a minus mu r minus 1 into a whole divided by mu minus 1 into a we can take, because of sigma which is equal to mu minus 1 into a. We can apply that formula here, right? So that by simplifying that we will get omega which is equal to mu v minus mu r whole divided by mu any one color, yellow minus 1, or else you can take mu minus 1. So by this way we can get the dispersive power of a particular color, right? So the scattering of light, blue color of the sky, and red is appearance of the sun at sunrise and sunset.